And then we have question 3c. This is interesting. I'm going to start by finding oxidation numbers again. This is +2, +1, which means this whole thing is -1. So since oxygen is -2, which is -6, you need that to be +5. And then bismuth, Bi, become +3, -2, +7. So manganese has an increase in oxidation number from +2 to +7, which means that it has undergone oxidation and it itself is the reducing agent. On the other hand, bismuth in this has gone from +5 to +3, so it is the oxidizing agent. I'm just going to quickly check whether I could split any substance that's already an ion, so you can't split that. Unfortunately, this is a solid, so cannot split. Cannot split. And that's already an ion, that's already an ion. So I don't think I can split anything. This is still under acidic conditions, so you could use cohes. So let's just start with oxidation. We're gonna go from manganese ion, Mn2 plus, to MnO4 minus. Okay, manganese already balanced. If we just focus on cohes, the next thing is to balance oxygen. I'm going to add 4 H2O, and then I would have 8 H plus on the other side to balance the 8 hydrogen atoms here. In terms of charge, the charge on the reactant side is now 2 plus, and the product is 7 plus. So you need to bring this down by adding 5 electrons, which does agree with an increase in oxidation number of manganese from +5 to +7. And I'm just going to add states in. Never forget states. So that's oxidation. For reduction, we're going to have NaBiO3, solid, going to Bi3 plus. Hopefully you should be able to identify, obviously, the main issue is I don't know how to balance the sodium, the Na, because it's definitely not something that you could balance using cohes. And this is one of the situations when you really do need to take some liberty, with reasons, of course. But if you think about what is happening here, just by looking at the reactant and the product, you have a solid, an insoluble ionic compound that essentially, as it undergoes a redox reaction, it has dissolved as the Bi is released from the ionic compound, becomes an aqueous, well, an ion dissolved in water, which means that the sodium potentially also is released from the ionic compound. And sodium ion is soluble in water all the time, because there is no change in the, well, there shouldn't be any change in the oxidation number of sodium, since you already have an increase and a decrease in oxidation numbers being accounted for. There must be an Na plus on the product side, so that sodium is balanced. Now that I have taken care of that, I'm going to balance everything else. So I'm using cohes. So the bismuth is balanced. I need 3 H2O liquid, which means I need 6 H plus, a Q, and so in here we're going to have the overall charge on the product side is +4, and this is +6, so I need 2 electrons, which does agree with the change in oxidation number of bismuth from +5 down to +3. Okay, so that's oxidation and reduction. Now, in order to add the two halved equations together, I do need to multiply the first one by 2 and the second one by 5 to get to a lowest multiple of 5 and 2, which is 10. And when you add them together, I think you're going to have to cancel out some water and H plus. All right, so I tend to do everything in one step, and this is how I normally do it. Anything that's not hydrogen and H2O or hydrogen, I'm going to write first. So you're supposed to have 2 Mn2 plus. We're going to leave the water for now and go straight to here. I'm going to have 5 NaBi O3. Be very careful of states. Once again, I'm going to leave the hydrogen for now and go to the product side. Leave some space though between them. 2MnO4 minus 5Bi3 plus and 5Na plus. Okay, so that's everything that's not water or H plus. Now, if you look at the H2O, this side on, well, the oxidation half equation, once you multiply everything by 2, should give you 8 H2O. And the reduction, once you multiply everything by 5, should give you 15 H2O. So if you have 8 H2O on the reactant side and 15 on the product side, you should end up with 7 H2O overall. And for hydrogen ions, if you multiply everything to this side, you should get 16H plus, whereas for the reduction, it will give you 30. So going from 16 on the product side and 30 on the reactant, I should have 14 H plus remaining. So I really have to do a charge check here. This is 14 plus and then 2 plus, which is 16 plus on the reactant side. The product side has 2 minus 5 times 3 plus 15, so 2 minus negative 2 plus 15 plus 5, which is 18 plus. So I have made a mistake somewhere. Let's see whether I could find it. Oh, okay. No, I think I know what it is now. The charge on this side should be 18 plus because you have 2 of the manganese. So 4 plus 14 is 18 plus. If you want to be extra careful though, you should check. You probably can do both, but or at least one, either oxygen and a hydrogen, and see whether it's balanced. So I'm going to do that because I just want to double check. This side should have 15 oxygen, 5 and O3. And then this side I have 8 and then 7. So that's 15. Well, may as well to check hydrogen. There's 14 on the left and 14 on the right. I think we're good for part C of question 3.